Okay, and then I can share. Wait. No, wait, there's some issues. I see something else. No, another notification there. Yeah. I have to remove that. Cool. Share presentation. It's good, Julie.
You're presenting this. Yeah. So if you stop the share and then share, that's great. I think that should
stop sharing. Then
if you share that one, yeah, that should hopefully do it.
Is it good now? Huh? Okay. So I'm just trying to see if there's switching the slides. Yes, slides can switching, right? Okay. So the platform is with Oscar and Thomas.
Okay.
Thanks.
Hello, everyone. Yeah, our talk is transfer learning with TAPAS from health to identity. I'll start off, I'll just introduce myself. I'm Oscar Forth. I'm one of the founders and the CTO of Oxford Wave Research. I've been the software lead on all of our products over time. So got quite a bit of a background in audio research and the development of our tools. I'll let Tom introduce himself.
Yeah, just quickly. Yeah, I'm Tom. My background's actually more linguistics based, specifically in phonetics and phonology. Did a master's in forensic speech science at York, where I studied or wrote about automatic vowel estimation and how that could be used in a forensic context. Now I sort of straddle both the research and the development side of life at Oxford Wave.
Yeah, I mean, these are the sort of areas that we cover. I won't go into too much detail on that, but suffice to say, our focus is on speaker identity, and we have a forensic tool, Vocalize, which is in use in various institutes around the world. But yeah, I mean, we got involved with the TAPAS project, and we were very excited to join in on the project. Over the time, we've attended various of the meetings, from the first one in Martigny up till this one, including the various ones on Zoom along the way. So, and during this time, we had Bent Halpern. He came and interned with us on 2 occasions, and he collaborated with us on various papers over that time. Something we have done in the past, me and the other founder, we worked on a healthcare product that was run on mobile phones called OperaVox. And through that, we sort of discovered that a lot of the same features that are used for speech and language therapy are the same ones that forensic phoneticians also use to help identify speakers. So things like the jitter, shimmer, and so forth. And we had, yeah, when Bent came when he came to visit us, we had a very successful internship with him. He's worked on various little things on there, from speaker-informed enhancement, voice spoofing and mitigation, as well as speaker clustering. And there's some of the papers, well, the papers that he collaborated with us on during that time. And we'll go into a bit more information on those papers and such like. So I'll hand over to Tom here.
Yeah, so in some actual examples, going first on this one, work that Bent and Rob have already touched on before there, in their detecting and analysing spontaneous oral cancer speech in the wild. They detected that there were often distortions in the speech of their oral cancer patients that isn't common in natural speech. And then they found that dilated ResNet-based architectures were particularly good at picking up these distortions and therefore detecting pathological speech. Sort of somewhat analogously, spoofed speech, like, for example, deepfakes and whatnot, also have distortions, although obviously quite different distortions, that are also not present in natural speech. So then, as what happened number 2, we sort of tried to see what would happen if we then took the same approach and applied these dilated ResNets to spoof speech to see if we could detect them. And sure enough, we found that there's very promising evidence that such ResNets could be used both as a spoofing countermeasure and as a detector for pathological speech.
That research did lead on to some research to do with deep fakes, and specifically sort of inspired when the invasion of Ukraine occurred. There, the Russians released a deep fake purporting to be Zelensky himself. And when we thought it would be interesting to analyze that, and Ben's did some analysis on that. I mean, it's basically goes to show that the synthesized speech, while it has huge benefits for improving the quality of life of people who have various pathologies, through things like voice banking and the like, it does have this potential downside. So we wanted to see whether we would be able to detect those deep fakes, and we did a study on various different data created by an amateur deepfake community, and it was able to distinguish with pretty high confidence that the difference between the deepfakes and the actual original real speech.
Right. Final example is actually almost a bit sort of the other way around, in that it was sort of looking at stuff that we were doing anyway, and it sort of are looking into identity sort of inform the health side of things. So in actually number 2, speaker informed speech enhancement and separation, we were looking at well, I should probably start actually on the main issue here, which is unintelligibility, which we've touched on loads over the past couple of days. As we know, it's a big issue for people who suffer from speech pathologies, particularly with assistive technologies and how they interact with like ASR. But also it's a massive problem with law enforcement, because lots of recordings have significant background noise, or just like recorded in like not ideal circumstances, unsurprisingly, and therefore like very deprecated recordings. So as people particularly interested in speaker identity, we wondered what happens if we include some speaker specific information in an enhancement process to make these recordings a bit more intelligible. And we found that actually, yeah, they were pretty useful in if you include these embeddings, that you get some enhanced audio that's a bit more intelligible. So Bent and I think Rob again, yeah, went and took a similar approach with their oral cancer patients again, and then used it in a sort of ASR system, and found that using speaker embedding, speaker specific information, they were able to like reduce word error rates in such a system, showing again that speaker information is extremely handy in both like health frontiers as well as in our sort of law enforcement environments.
Finally, we want to say thanks to TAPAS. We've had a great experience. There's been it's been a really good project. Like seeing all the research that's come out of it has been amazing to see, and especially over time, seeing how it's advanced. We hope various people have benefited from our inputs. We've certainly benefited from yours. We made some great connections with some of the researchers during this time, and special mention to Matthew, Ordeering and Therapy Box. And we hope we'll have a chance to work with you all again. Thank you.
Thank you very much, Oscar and Tom, for the connecting speech, pathological speech and speaker identity to speaker research. That was wonderful. And so we have 2 recordings to present. So the first one will be, stop the recording.